So hey nerds, this would be the third video of our calculus lecture series. Whether I have to call it lecture or not, it is going to be a very much fun part, and you can actually learn very much more thing about calculus, how you can manipulate the algebraic terms, how you can substitute the relationships, and etc etc. So, and if you had any problem in your calculus workshop right, in your calculus journey, so you can actually comment your just the problems, or we had opened the community tab for everyone so that the knowledge would not be a barrier right? So you can actually comment your problems in the community post, and I would be picking up the uh, relevant, yes, relevant problems that I can solve by my own. There would be many more problems that I cannot solve by my own, and I need some guide. So if there would be any problem left, I would be asked to with my professors and teachers, and if I can solve it, I would do that. And just don't try to send the good and easier examples, right? Just integration of x dx, dx over x, not that type. I'm quite good in math, but don't try to send me some basics problem, right? So this would be the third video, and we are going to integrate some problems. So you can actually enjoy this video, and you can actually learn from. If you want to copy this video, you can actually copy and post. It would not be anything that would affect you in your own YouTube journey, right? So you can actually copy my video, and you can actually share it everywhere. I don't care. So if I am earning, you might you have to also earn. So after there, bye bye, and let's dive into the whiteboard, and let's do the third integral problem. And don't forget to share your problems with me, right? The problem solved, I will be solving your problems in next videos, right? So let's go. Let's go into the third integral of our this integral or calculus video series, and we are taking a beautiful example, that is with this respect to x, that is what we have to say. We have done a squared plus x squared, a squared minus x squared. Now we're going to take x squared minus a squared, right? X squared minus a squared, right? Right. Okay. So an integral can be done in very much different way that we think. You can do with the substitution, you can do with the help of some algebraic manipulation, and now I'm going to do here the same thing. That if you let me do this, if I take x plus a, right, and okay, not this, x plus a minus x plus a. So the minus and plus will cancel, we will get 2a. And if I divide this with 2a, I got the same relation, and that is x squared over a squared. So is this clear to you from the perspective of camera? Right, it would be clear. Now notes, what we can do, we can actually separate our integral. Yes, integration can be separated. If you have x plus y, whether I have to call it y or not, so let us assume just there will be some variable. These are variables, so you can actually separate like this. So these can be separated in based on that. So before separating, let us do another form, that is x plus a minus x plus a, and with respect to x, and let us divide this. Why we are going to, you can actually ask me, why Suman you are going to separate this? So because I see an symmetry here. Yes, you can also see an symmetry here, but you have to do a lot of more integral problems because it doesn't come out on the regular basis. So if I separate this integral from this point of view, I will get this term cancel out, and something like minus will, if I take minus common, and something will take common out, and we can actually just put in terms of logarithms, right? So let's do here, that is 2a integral. So I'm going to separate this like x plus a dx divided by x plus a and x minus a, right? So and minus, I have again 1 over 2a because it is going to multiply with both sides, and I will get x, sorry, so if I had taken minus common here, whether you believe me or not, okay, let's do up to here plus sign, take x plus a dx over x plus a and x minus of a, right? So I can actually cancel out this. So I will end up getting 1 over 2a integration, that is dx over x minus of a, right? So now if I take minus common from this side, I will get minus 1 over 2a integration x plus a, x minus a dx over x plus a, x of minus a, x into minus a. So x minus a and x minus a will cancel out. And if I take this both common, I will get 1 over 2a and integration dx over x minus a minus integration dx over x plus a, and this would be our thing, right? Up to there I think it is clear. So if you know that integration of dx over x is ln x, it is ln x. So this is going to be, if you add x, you will get x here. If you add x minus a here, you will get x minus a here. So this would be 1 over 2a, right? And this would be integral. So this would be dx over x minus a. In terms of ln x, we can write ln x minus a minus ln x plus a with some constant c, right? So this would be 1 over 2a, and I would like to show you some property of log, that is ln a minus of ln b is ln a over b. Ln a minus ln b can be written as ln a by b. So ln, so right in here we can write 1 over 2a, right? It is ln x minus a by x plus a with some constant c, and the final result would be 1 over 2a ln x minus a x plus a plus some constant c. So this would be our third identity, and this would be the third video of our lecture series, whether a practical lecture or just some fun part of doing calculus. So you can actually replace integral dx over x squared minus a squared is 1 over twice of a ln x minus a over x plus a with some constant c. So up to here this much, and if you want to share your own integral problem with me and you want it to be done in the next upcoming videos of mine, you can actually post it in our community. So the community is actually open, and don't post anything that would be awkward to audience and to me also. So you can post your problems so that I can pick that problem from the community box and can help you in doing that. So up to there, bye bye.